Imagine trying to find the biggest, heaviest fish in a river that's rushing past you at 100 gigabits per second. In the world of computer networking, this is exactly what engineers have to do. Identifying the heavy hitter flows, the streams of data with the largest traffic volumes, directly in the data plane is critical. It helps networks route traffic efficiently and detect denial of service attacks before they crash the system. But doing this is incredibly tough. Switches have to process packets at line rates of 10 to 100 gigabits per second. At those speeds, the switch only has a tiny time budget, sometimes just 1 nanosecond, to process each packet and update its memory. Existing solutions aren't great. Packet sampling, like NetFlow, forces the switch CPU to work too hard, requiring incredibly low sampling rates just to survive. Other methods, like sketches, use way too much memory to retrieve the heavy hitters. Enter HashPipe. Proposed by researchers from Princeton, Rutgers, and MIT, HashPipe is a heavy hitter detection algorithm built entirely in the data plane for emerging programmable switches. Instead of tracking every single packet, HashPipe uses a pipeline of hash tables. Its goal? To keep the counters for the heavy flows inside the tables, while ruthlessly evicting the lighter, smaller flows over time. Here is how it works. When a new packet arrives, it is always inserted into the first stage of the pipeline. If there's already a different flow taking up that slot, that existing flow gets evicted, but it isn't deleted. Instead, its key and count are carried along with the packet to the next stage in the pipeline. At the next stage, a battle takes place. HashPipe compares the flow it's carrying with the flow currently sitting in the table. The winner, the key with the larger traffic count, gets to stay in the hash table. The loser, the lighter flow, is carried forward to the next stage, or is completely kicked out of the switch if it reaches the end of the line. This clever design smokes out the heavy keys, keeping them safe in the limited memory while maintaining a feed-forward design, meaning packets only have to move through the switch once without stalling. The researchers built a prototype of HashPipe using the P4 programming language and tested it against massive traces of real internet and data center traffic. The results are incredible. On an ISP backbone trace containing 400,000 unique flows, HashPipe successfully identified 95% of the 300 heaviest flows using less than 80 kilobytes of memory. That's just 4,500 memory counters to accurately track a river of hundreds of thousands of flows. At that tiny memory footprint, it outperformed the sample and hold method by over 15% and an enhanced count-min sketch by 3 to 4% in terms of false negatives. HashPipe proves that with smart pipelined algorithms, we can track massive network hogs in real time, entirely within the extreme constraints of modern switch hardware. If you want to read the full technical details, check out the link to the paper in the description. Thanks for watching.